Hi, welcome to Sachun Study Tech. Today topic is N-Queen problem. So N-Queen problem is one of the application of backtracking. So N-Queen problem is a classic backtracking problem where you must place N queens on N by N chessboard such that no two queens attack each other. That is, this is the bounding function. So no two queens are in same row and same column and same diagonal. So this is the bounding function or constraint. If that solution must satisfy this constraint, so these are the simple steps. Here you can see, try placing a queen in each row. For each row, try each column, check if it is safe or not. If safe, place the queen and move to the next row. If placing leads to dead end, backtrack, remove the queen and try next column. So the time complexity of this n queen problem is big of n factorial. Space complexity is big of n. Now we can discuss 4 queen problem. 4 queen problem consists in placing 4 queens on 4 by 4 chessboard so that no two queens attack each other. Already you know this is the bounding function. That is, no two queens are allowed to be placed on the same row, same column and same diagonal. This is the bounding function. So first I am fixing here, it is q1 is placing in the first row, q2 in placing in the second row, q3 is placed in the third row, q4 is placed in fourth row. It is fixed. Now the column may be vary. So for example, q1 is placed in first column or second column or third column and fourth column, like that. So for example, here how many total number of nodes is there? So you can see here it is, after fixing these queens in the rows, here it is q1 in first column, q1 in second column, q1 in third column, like q1 in fourth column. Now q1 in the first column, now we can expand. Here it is, backtracking follows the DFS, that's we can expand this one. Here it is, q2 is second column, q1 in the first column, q2 in the second column. Now we can expand this, q2 in the second column, here it is q2 may be in third column, q2 may be in fourth column, like next. Here the q3 in the third column or q3 may be in fourth column. Here it is, q4 is in fourth column, here it is q4 is third column, like that you can expand. So how many total number of nodes is there? This is a state space tree, solution tree, also called as a permutation tree. Here it is, how many total number of nodes is there? You can see here. In this case, here it is, first you can see in this level one root node is there. In this level 4 nodes is there, 4 nodes. In this level you can see, so 4 into, here it is 4 into 3 nodes is there, 3 nodes. Here also 3 nodes is there, that is 4 into 3, 12 nodes is there in this level. Next, here the 4 into, here next level is 2 nodes is there, 2 nodes. Here also 2 nodes is there, 2 nodes. That is, in this level 4 into 3 into 2, that is 24 nodes is there in this level. Now you can see here it is, you can expand, 1 node is there, 1 node. here in this level 4 into 3 into 2 into 1 node is there, that is 1. So total is 65. So what is the formula for this total number of nodes? Total number of nodes, total number of nodes, here it is, formula is there, that is summation of, so k equal to 0, so k equal to 1 to n, here k equal to 1 to n, product of, so I equal to 0 to k minus 1, here it is k minus 1, right, here it is n minus i, n minus I. So that is equal to 65 total nodes is there. So you can see here it is 1 plus, this is the formula, 1 plus k equal to 1 to n, product of I equal to 0 to k minus 1 n minus I. So here you can see 1 plus, here it is 4 nodes is there, that is I equal to 0, that is n value is 4, 4 minus 0, that is 4. Next 4 into 3 plus, if I equal to 1, 4 into 3, like here it is 4 into 3 into 2 plus 4 into 3 into 2 into 1, here it is 24, here it is 24, here it is 12, here it is 5, here you can see 24, 24, 48 plus 12, 60, here it is 5, 65, total 65 nodes is there. But here, but the constraint is the two queens are in the same row or same column or same diagonal. But here you can see q1 in can fix the rows, but you cannot fix the column and the diagonal. So here these number of possibilities is there. Now if we can satisfy that constraint, how many possibilities is there, now we can discuss how many number of possibilities is there. But here the q1 is fixing in the first row, q2 is fixing in the second row, q3 is fixing in the third row, q4 is fixing in the fourth row. Now we can see here it is a root node here, q1 in first column, for example q1 is placing here, q1 is placing here. Now you can see here it is q2 is placing in second column. Now we can see q2 is placing here, it is q2 is placing here. Now it is a diagonally attack. If you can expand this, there is no solution because here diagonally attack, so that you can kill this node. Now we can see backtrack, q2 may be in third column, so q2 may be in third column, so here there is no attack, then you can expand. Now we can see q3 in, for example here this q3 is not placed in this case because the same column. Okay, here also you cannot, for example q3 is placing here because there is no queen here, that's why q3 is second column. Now you can see q3 in second column, here it is q3 in second column, but here the diagonally attack. So go backtrack, and q3 in, for example here q3 in not placing in this case because here q2 and q3 are same column, so that q3 is placing in, for example fourth column, here q3 is placing in the fourth column, but here also diagonally attack, you can kill this. Now backtrack, q2 is placing in fourth column, here it is q2 is placing in fourth column. Now you can see here it is q2 is placed here, then Q3 is placing in this case second column. Now Q3 is Q3 is placing in second column. Here you can see there is no attack. Then Q4 is placing, okay, which column is empty? Here it is, already Q1 is there, here Q3 is there, here there is no queen, here Q2 is there, so that this column is there. So you can place the Q4 in this case. Q4 placed in third column. It is also diagonally attacked, so it is not a solution. So backtrack. So Q3 is not, there is no place, then backtrack. Q2 is, there is no place, you cannot move to anywhere, so backtrack. So Q1 is placing in, here you can see Q1 is placing in the second column. Now you can see Q1 is placing in second column now. Okay, Q1 is placing in second column. Now you can see here it is, Q2 is not placed here because it is diagonally attacked in first column. Q2 is not placed here because it is the same column, so cannot place. Here also in third column also Q2 is not placed here, it is a diagonally attack. So Q2 is placed here in this position. Now we can see Q2 is placed in fourth column. Q2 is placed in fourth column. Now we can see here it is, Q2 is placed in fourth column. Now Q3 is placing in first column, in third row, first column, and Q4 is not placing here because in the same column Q1 is there. Q4 is not placing in this, here Q1 is there. Okay, now here you can see Q3 is placing here, Q4 is placing in third column, so Q3 is placing in first column and Q4 is placing in third column. This is one solution. Now you can note down here, already queens are fixed in the rows. Now you can find out the columns here. Q1 in second column, column numbers, Q1 in second column, Q2 in fourth column, Q3 in first column, Q4 in third column. This is one solution. Another solution is, you can expand this tree. Another solution is, for example, this is the mirror image of this. You can see here it is. So Q1 in here the Q1 is here, and Q2 here, Q2 and Q3 here, in mirror image Q3 here and Q4 here. You can see Q1 in the third column, Q2 in first column, Q3 in fourth column, Q4 in second column. This is the another solution. So we have to find out n queen problem. The 4 queens are placed in this chessboard in these ways. So it satisfies the condition. You can check here it is, no 2 queens are in the same row or same column and diagonal. Okay, thank you for watching this video. Later class we can discuss about 8 by 8 queen problem.